welcome. If you, like most people, didn't read the talk description, you would be excused for expecting this talk, we're snaking it live, to be about my brand new snake principle for software development. Or maybe you're here thinking this talk is going to introduce Snake.js, a new broccoli plugin that makes JavaScript white space sensitive. You know, like Python, get it? Or maybe this is finally my chance to objectively prove that what you really need is snake case and tabs and Hungarian notation. No, this is sadly not that talk. This talk will be about AI, minus the marketing, the hype, and all that groaning, real JavaScript that miraculously manages to be fun to write, and jokes, where we'll put all that groaning we removed from the AI part of the talk. But to do that, we're going to play a video game. Who here has played a game of Snake or otherwise knows the rules? All right, a decent amount. Who here played Snake on one of these? All right, I found my people. Who here played this version in Quick Basic for... Hell yeah! All right, we got a couple... Last time I gave this talk, no hands. I was so sad. But for the uninitiated, or those that don't get that nerdy with the game rules, here are the rules. So in Snake, time moves on like a ticking clock. And each tick, your snake moves forward in the direction that it's facing. Press an arrow key to change the direction that you're facing. Pressing the right arrow makes your snake move right, not turn right. If your snake collides with that version's MacGuffin, a fruit or a number or something like that, it grows in length by 1. If your snake collides with anything else, a piece of itself, the wall, it dies. And your goal is to live as long as possible under those conditions. Clap once if you're still with me. Yes, this will be a thing. 1, it tells me that you're still with me. 2, everyone over there and in the hallway thinks my talk is so good that you just can't keep yourself from clapping. But if I lose you, please do 2 things. 1, don't clap. That way I know. And 2, come find me later. I'm happy to clarify anything that I'm going to talk about today if it's still unclear after 40 minutes of this. But if this is a JavaScript talk, this is where I start teaching you how to make your own Snake game, right? We're going to talk about sockets and using Canvas to do rendering and client-server optimism and latency, and no, it is also not that talk. Instead, we're going to flip that talk inside out, upside down, shake out its lunch money, and write some code that plays Snake. We are going to write a Battlesnake. Though if you'll excuse me, I've already skipped the worst part of my talks, the introduction. Hi, my name is Michael Schoonmaker, but nobody calls me that because it's too long, too formal, and there are too many other middle-aged white dudes named Michael running around, so everyone calls me Schoon. I have the honor and privilege of being a freelance consultant these days. Me and a dear friend of mine run a company called Legacy of Play, but my interest in today's topic comes in our work making games. In fact, if you like tabletop games of any kind, come join us next weekend up in my neck of the woods for something called Unpub. After 4 cross-country moves, my wife, myself, our 2 kids, and our dog live just up the road in Baltimore, Maryland. And we'll be in Towson next weekend for that Unpub event. It'll be just tons of board games. If that's your cup of tea, come find me and I will talk about what that is. Pertinent to this talk, I also happen to be in the top 20% of all Battlesnake players. So what is this Battlesnake thing then? Well, Battlesnake is live multiplayer Snake. The rules are mostly the same, but with a few additions. So each snake must eat something every 100 ticks, or it dies of starvation. Each tick is about 500 milliseconds, so your snake has a little under a minute to live without food. And for a standard match, food shows up about every 3 seconds. If a snake hits the usual stuff, the walls or itself, it dies. If 2 snakes collide head to head, the bigger snake wins and the smaller snake dies. Otherwise, if it's a tie, they both die. And you can play it right now at play.battlesnake.com. Insert a joke about this talk being over. Cue laughter. I said, all right, perfect. And I've just bought us all another half hour of vacation time, right? All right, well, shoot. I suppose this is a JavaScript conference, and we should probably write some JavaScript. So, I first heard about this Battlesnake game from an early investor of ours. And I'll keep them anonymous to protect the innocent. And no matter how much respect I have for that individual, they weren't the sort that I was going to take video game recommendations from. We all have that friend who recommends the movie that gets good after the first hour, or who recommends the book that's been out of print for 10 years, or who on their birthday every year fires up Zelda, the Ocarina of Time, because that's when gaming peaked. But I wound up wanting to design a game with programming. So after the contemporaries like Code Wars or Screeps or TIS 100, I remember this dumb Snake game, and I opened up the website. The goal was clear enough: write some code that plays Snake like it's still 1991, but where's the editor? Where do I go through with some horrible microtransaction and unlock a turn left block? But I was wrong. It wasn't just some dumb Snake game. And much like Spider-Man late on the way to his second shift as a bartender, each snake actually runs as a web server. The first is a sort of info route where you describe the appearance of your snake. The head, the tail, what color, and who is responsible for this crime against nature. The second, a start route, tells you that your snake is about to be entered into a multiplayer live match. And a similar end route tells it that the match is over and who won. This last one, the move route, is the real workhorse. You get an updated view of the board, and you respond with a single response: up, down, left, or right. Which way does your snake turn this round? Again, you have about 500 milliseconds to respond, or else it's going to keep going where it was going before. Clap twice if this is all clear as mud so far. All right. So before we get too much further, let's actually see this in action as I Julia Child a couple of snakes that I built earlier. So you can see that each one is being given the same request that we talked about, and in pretty short order. You can see the latency up in the corner, right? So in 40 milliseconds or less, they've decided on which way they want to go, and they're responding with up, down, left, or right. They're moving around the board, and they're eating, growing longer, trying not to slam into something or, one another. All right, and these snakes use the 3 techniques that we're actually going to talk about today. They use something called flood filling in order to avoid tight spaces. They use pathfinding to seek out the food that's on the map. And they use something I call height mapping to better understand the other nuances on the board and make decisions in sort of the gray areas. These are the same techniques used in the live AI of video games. And I know that video game and web developers love to pretend sometimes that their work is so different. But if my career is any indication, they're really not. And I'm at a web conference, so you're going to get a talk on video games. One last disclaimer. I don't work on Battlesnake. I don't have snake skin in this particular game. And the people who are the core contributors likely didn't know I existed before I warned them that I was giving this talk. So then why am I the one blathering on about this for a full 40 minutes? Because yes, this slot is slightly longer. It's because I think that it's the best way I've found so far to play with code. If I want to write or learn a new framework, I'll write a snake in it and give it a shot. Maybe I want to learn how to optimize JavaScript and get it to respond in as short a time as possible. Or if I wanted to learn some new AI technique that's rapidly taking over the center of this programming game that we're all playing, I could build 2 snakes using different techniques and have them face each other. So you could build a neural network for one and a generative pre-trained transformer. That's what GPT stands for. on the other. That, and it's just fun. The community has been kind and curious and welcoming, and it's one of the most mutualistic and positive tech spaces on the internet that I'm aware of, and I don't understand how that kind of thing is allowed to exist. You don't even have to publish them or compete on their leaderboard. The tools are open source. They're written in Go and SvelteKit. I actually had to edit them to get the talk to work the way that I wanted. We all know how good conference Wi-Fi is, so relying on their public servers seemed like a bad choice. So getting it all working entirely locally on my machine was totally doable by downloading their tools, talking to a couple people on the Discord, and making the edits that I needed to make. But if I'm going to tell you it's that easy, and the playbill says I'm live coding this, we should be able to make a snake right now, right? All right, well then let's make a snake that follows those basic rules, even if it's not going to do very well. To do this, we're going to hop over to VS Code. There's a little mise en place here, as I've already created the node project, and I've installed Express and TypeScript. In the terminal down at the bottom, we've got a little watcher that'll restart the server as it changes. But in our server.ts file, let's go ahead and create our first 4 routes. I'll throw in some Express boilerplate. I apologize as I turn away from the microphone each time. But we've got our get for info. And we want a rec and a res. And then, so we want to respond with, like I said, what color is it, the head, the tail. And for author, front runners. Perfect. And we need to do some basic start, rec, res, right? Okay, here we go. And we can respond with just a good old courtesy, 200, everything's cool. Nothing to see here. And likewise for end, get our res.send, nothing. And then we need to do, like I said, the workhorse is this move route. And we need to decide which way our server wants to respond. And we're going to do a move. And our strategy will be known as, you can't go wrong if you always go right. So we give that a save, and we can test this out with, we have a little run script here that will use those local tools to run through a program to run our snake in a totally empty room all by itself with no other snakes and no food, and watch it die. And look, success. If we go back over to our slides, we can actually watch this happen. And sure enough, our snake always went right. It slammed right into the wall. Double success. All right, clap once. Perfect. Glad you're all still with me. What if we don't want to hit the wall? For that, we're probably going to have to introduce some tool that we can use to think. And before that, though, a quick aside for any folks that don't have the misfortune of a formal computer science education, we're going to talk about graphs, but not this kind of graph. This kind of graph. This is a graph. This is another graph. Casey, can you grab them back for me? This is a tree. Trees are a subset of graphs. Trees, you could say that trees are to graphs what paper people are to pieces of paper. Technically, this is a piece of paper, and it'll take ink exactly as well as any other. But if the person sitting next to you asks you for a piece of paper to take notes on during this flawless and hilarious talk, this is strictly the chaotic evil option. In case either of these words fall out of my big mouth in the next 20 minutes, a node is any of the places on a graph. And the edges are the lines that go from one to the next. This is where we could talk about directed graphs, or cyclic and acyclic graphs, subgraphs, and coloring, but we're not going to. What we are going to do is acknowledge that our playing board is a funky sort of graph. Every space on the board is one of those nodes, connected to every other adjacent space with an edge. If those lovers of Greek letters and Arabic numbers, math nerds, have come up with any tool for working with graphs, we can now use it to play Battlesnake the way God intended. You know what to do. All right. So now that we've discovered this new toolbox under a desk over in the math department, let's go back to our snake and its tendency to try to Kool-Aid man itself off of our board. The root cause is that while we currently get the board state every move, we don't use that to make our decision. We'll start with the simplest. It's called flood fill. And for those of us, and a few of you raised your hands earlier, old enough to remember MS Paint, this is the algorithm for this tool, the bucket. So here we have some TypeScript for this. We start with a space that we want to think about here. And at the bottom, we've got if that space is safe, if there's nothing there, there's no wall, there's no other part of a snake, then we want to track that one and then recurse, flood filling in every direction from that original space. If this is a space that we've seen before, we don't want to double count it. And if that space isn't safe, then we can back off and start popping those frames off the stack. And pretty quickly, we can recursively calculate for any start direction, how big is that contiguous area? And if we let this run, you can see that with just that one algorithm, our snake completely avoids both the walls and itself and lives long enough to starve to death. Glorious. All right. Hearing the claps a little bit quieter. Hopefully we're not losing too many people. But how do we find food? Real snakes have an incredible sense of smell, but our snake wouldn't be able to see a burger and fries right in front of its face. There could be someone microwaving fish just one space away, and it wouldn't even notice. But fortunately, like taking surfing lessons in a banana suit, we're told exactly where the food sits on the board. So how do we use that knowledge to make our snake actually eat it? Because the first step of solving any programming problem is knowing what to Google, or I suppose what to type into Slither GPT these days. The domain of problem that we're talking about is called pathfinding. We're going to use a variant of Dijkstra's algorithm for this called A*. It's called that because computer scientists are famously good at naming things. What makes A* a little bit more complicated than that first flood filling algorithm is all the terminology and bookkeeping that it uses, so we're actually going to start there. As we go, we will be scoring spaces. Score is, like anything in computer science and math, an abstract term here. But in our case, what we're concerned about is how far away something is. So for score, we're going to worry about distance. And the first step of that is to use something called a heuristic function, which is mathematician speak for we're going to guess. We'll keep track of every best known score that we have, called G for some reason, as well as the space that we used to get there. And then finally, we have something we call the open set. It's a priority queue of all the spaces we haven't looked at, sorted by that score so that we know which ones to look at first. The algorithm then, like say buying your very own Barbie dream house, comes to filling out all these forms. This first part here, we're setting up all those data structures that we just described. And then here we've got for our open set, we're going to pop off the highest priority item in our open set. If this is the exact space that we are headed to, well, then we're done. Go back through that where did we come from map and build our path from beginning to end. Otherwise, we're going to go get the current score, we're going to open up pathfinding next door, and we're going to ask it about all of its neighbors. We then, for every neighbor, want to figure out what the score would be to get from here to that next space. And if we found an improvement, if the score that we found, that distance that we're starting to calculate out from where we started to where we got, if that's better than what we already thought was true, then we're going to save that to that map of best scores. And we're going to make sure that it's prioritized in our open set so that we can keep working. All right, perfect. And now you've got a pretty key tool. That's a pretty key function in doing game AI, writing programs that play games. One of the pieces that I skipped over here was that heuristic function. How do you teach a computer how to guess? But here's what it is. All I want to point out is how simple it is to the point of being naive. We only really need to be just good enough to sort that open set. More specifically, we're told as long as it sorts our open set from best to worst, it produces scores that are equal to or strictly worse than reality, and is strictly positive, all of the numbers must be positive, then our math nerd friends will guarantee us A star finds the best path to the goal. And we can see this in action. You can see that at any given step, the snake will run after a piece of food, and it pathfinds from where it is to where it wants to be. It avoids itself. It continues to avoid the walls, and it finds the most optimal path that it can to get there until, as this weird chimera between a goldfish and a snake, it has grown so big that it fails to fit in the space provided anymore. Oh, that's so good of you to applaud for our little snake. All right, well, we covered flood filling to understand the difference between, say, a wide open plain and a New York City apartment. And we covered pathfinding to establish how we might get from a wide open plain to that New York City apartment. And thirdly, like a couple of dogs walking through Central Park in autumn with all these beautiful leaves scattered across the ground, I want to talk about the gray areas. Remember, A star was about finding an optimal path to a known goal, and flood filling was about establishing where the safe areas were. But being really good at a game comes in that nuance between something that is optimal or something that is safe. So I want to leave you with one more technique that I call height mapping. If I was smarter or I paid better attention in school, I might have named it after myself or some other white dude, or included words like tuning or bias, but I didn't, and I'm not gonna. And like two halves of a Haribo twin snake, you are stuck with me just as I am stuck with a wife and two kids that like these disgusting things. But first, I realize you might be sitting there thinking, hold up, Schoon. You talked about AI, but you didn't really talk about AI, to which I'd say, all right, fair enough. So let's talk about neural networks. I know it's a hot enough topic right now that you've seen everyone and their poodle explain how these and large language models work, but I'm going to give you the basics again anyway. A neural network aims to replicate some of how our brains work with a graph of nodes and edges cleverly called neurons. On the left side here, you've got a set of these input neurons. You feed into it the set of parameters. Hey, here's the state of the board in our snake case. And on the right side, we've got these output neurons. You could have, say, 4 of them. One weighted for going left, going right, going up, going down. And theoretically, if we feed this the current state of the board, it will give us some fancy, fuzzy answer out the right side. And as a mathematical tool, it's incredibly powerful. So why did I waste 20 minutes of your life talking about something other than CNNs, GANs, GPTs, and other TLAs? I accidentally left behind my case of props. Thank you to the organizers for lending me scissors to make this one again. But this is a donkey car. It drives itself using a library called TensorFlow. It's designed to race against other very autonomous cars its size, and the one that I built and left at home is very cool. Thank you very much for saying so. I told you what this layer is called, the input layer. For this car, it's built from what it sees up front. It has a little camera on the front of it, and it can see what's in front of it. And I told you what the layer on the right is called, the output layer. How much throttle should it give? Should it steer left or should it steer right? Do you know what these two layers in the middle are called? Hidden layers. They're called hidden layers, exactly. I didn't teach you about neural networks because they have a pernicious risk to them. And no, I'm not talking about the collective carbon costs of running something like ChatGPT using more power than a developed nation to help you optimize a SQL query. No, this risk lies in the hidden parts of those hidden layers. While those weights I described, so each of these edges has a weight for following that one versus the others, well, these weights I described could be hand-tuned. Nobody does that. They feed in a set of training data and work the machine through that training data, establishing those weights to fit to the training data. And then, theoretically, they reserve some of the data that they have, very cleverly calling it the testing set, to then test that model and see that it produces the same result in the future on a second set of data. For our car example, I can drive the car around and I've got a little remote control and it's seeing how I feed it input over time, steering it left, steering it right, and it's watching the camera and figuring out some theoretical relationship between what it sees and what I want it to do. Now what happens? If you deploy this network, feed it real-world input, and it produces an output that you don't expect. What happens when I tell that very same car to go, and it careens into the nearest ditch? Does anybody know? You shrug, which I see a couple of you doing already. Why did GPT-17 hallucinate some horrible, offensive, or wildly counterfactual output when asked about such and such a topic? Shrug. Why did a much bigger self-driving car slowly lurch through an active and roped-off crime scene? Shrug. Why did Apple Maps send me down a dirt road when the highway was right there? Well, that's maybe a bad example because it's just doing pathfinding, and we talked about that a couple minutes ago. But more importantly, and back to the point at hand, why did my snake go right when clearly left was the right choice? Shrug. But I'll tell you a secret. What I am teaching you today is AI, but it's AI that a human can observe and understand live. You are learning about it right now, live. I told you so much at the top. These are the same tools used today in games from Baldur's Gate to Minecraft. They're older than Doom, and I'll tell you, Game of the Year 2030 is going to use all of these same AI techniques. Your marketing team can still call it AI with all the branding while you use techniques that keep a human in the loop, that a human can fix, and whose decisions are clear to the brilliant humans like you that build and maintain it. And yeah, this is real AI branding from these companies. So at least for today and for now, and while our goal is more play and have fun than win at all costs, we're going to make like a peanut with a Geiger counter and avoid the radioactive elephant in the room. Back to height maps. What we want to do is take all this information, other snakes, walls, food, and the like, and compile a height that accounts for all of them simultaneously. Higher terrain is riskier terrain, and lower terrain is safer terrain. And all else being equal, our snake will slither downhill. I lied earlier, though if you ask a small child, it's not lying. I simply didn't tell you the truth. There's one more rule in Battlesnake, and it has to do with these things called hazards. The reason that your snake dies after 100 turns is that every time it moves, it loses 1 health. If you hit a hazard, you lose up to 15 health for that full round. You can see the math over there on the side, but really hitting a hazard is way worse than any other move, say crashing into something. But this does give us good input for what we can use for our height map, and it should correspond to the literal risk to a snake's health. Remember that scoring discussion we were talking about with A* earlier, and I said it was abstract and we were going to use distance. Well, this gives us an even better score. We can actually track the real risk to life and, well, it's a snake, so I'm not sure limb applies, but you get the idea. We can assess the risk to the snake, how much health would it lose for a given move, and use that for our score. And then by the time that we're done, the path that A* will consider the best is the safest one through all of these various obstacles. There's not even a new algorithm here. We really need to worry about the data structures. Battlesnake, like most APIs, I'm sure y'all are dealing with APIs in your daily work, they give you the structure that best benefits them as a platform. And in the Battlesnake case, it's an array. We have an array of food and an array of hazards and an array of snakes. And what we really want is to get down to a single map of, for this space, how tall is it? So what we're going to do is we're going to loop through each of those arrays. We're going to loop through the board and calculate the height based on it has food, add to the height. It has snakes, or it has food, lower the height. It has snakes, add to the height. It has a hazard, add to the height. With one caveat, you'll notice some funky math in here. We need to make sure these scores stay positive. We have something called an infinite loop. Those, I understand, are bad. But as long as we do that, we get our height map. And let's see this in action. So this is a customized game that puts hazards a little hard to see on this screen with the lights. But what I'll do is I can trace out this here. These are some hazards. Oh, I'm getting some feedback too. Sorry about that. These are some hazards that it's used to trace out a map. And so you can see how there's a piece of food on the board. And our snake is going to use that same A-star algorithm. But now it knows that there's a difference in the terrain. And as soon as it makes it to the food, the map resets. And there's some sort of oddness here, which might just be proof that we actually did write this in JavaScript. Ooh, I'm getting a FaceTime call. It's funny. That's my friend. We talk literally every day. And he said I should call him from stage. I think he's just trying to make that happen. All right, with that, we're playing the game, and we're playing it reasonably well. We won't win the majority of our matches, but most snakes don't. What I wanted to talk about next then is, where would we go from here? Like, if we wanted to make it even better, what would we do? Well, how about some basics? Decision making. Our snake wants food like Joe Biden wants to be cool. All right, I'm going to tell you a little trick. If you option click your calendar up here, it turns on Do Not Disturb. So we're going to do that. I should have done that beforehand. Decision making. Our snake wants food like Joe Biden wants to be cool. Back to that joke. But it doesn't have to be that way. We could elect someone who's not an octogenarian white dude to the White House, and we could teach our snake to prioritize safety, survival, over its bacchanalian feast. Frameworks. We wrote this in Vanilla Express, but I'm sure you could write this even more succinctly in whatever framework you actually use every day. Languages. We wrote this in TypeScript, but there are snakes written in Kotlin, C++, Python, Go, Rust, Java, and even Bash. There are actually very few snakes competing with JavaScript right now, and I think that's a shame. Hosting. We ran snakes right on this laptop, but competitive snakes, some serious air quotes there, run in the cloud somewhere. DigitalOcean, Linode, even Oracle Cloud, I know. How small of a device could you get it to run on the opposite end of the spectrum? I want to see that this year and see if I can get it down to those little, smaller than an Arduino devices, if I can get a snake running in my closet in one of those. Getting more advanced on the technique side, there's a technique called minimax we could use to make decisions. It's completely orthogonal to what we did today. It involves simulating potential futures of the game based on what you and everyone else has done, which also makes it way out of scope for a talk like this, but it is commonly used for things like playing chess, playing Go, and even in Battlesnake. Genetic algorithms are a generational process that's more straightforward than it often gets described as. And we could use one to say weigh the priorities between some of these algorithms that we talked about today. And if you are considering generative AI, I'd again recommend a platform like Battlesnake to mess with it. It's a low-risk sandbox to learn and experiment inside of. And I may not be an expert, but I'm convinced there's some way to make these models more observable in production than they currently are. All right, I promise that's the last one. But even with all that, how good is our snake already? Let's put it through some paces, and we're going to play Battlesnake. And so to do this, I'm going to walk you through some of the game modes in Battlesnake, and we're just going to look at some of these demos. We're going to start with the smallest and the simplest, which is called Duel. And to make things interesting, the snake on the top is another, we'll put another snake in the ring, and this is the one that I actually keep in competition. It's a long-running competition and runs games every night, and so this is the one that I keep on a server somewhere written in Rust. And you can see the two off to the races, chasing after food, trying to grow, trying to be bigger than the other snake, and eventually, I don't remember even which one wins. There you go. And you can see on the left, on the right here, it said that they tried to go head-to-head. We can back up a step. And it just so happened to get to the point where, as they both collided together, one of the snakes was longer than the other one. And as we talked about earlier, that means that one dies. But awesome. Here's a standard match. So this is another game mode that they run. And in this case, it's 4 snakes. And to make things more interesting, I actually went back. And here we can pause it and play it another time. I went back and brought in the snakes at every step. So the flood fill one up here in the corner, that's the one only doing flood fill, and then A star with A star, and height mapping with height mapping, so forth and so on. And you can kind of see the level of competition between the different algorithms that we used. And it turns out A star by itself, still pretty good. Constrictor is a little different. There's no need to eat because your snake will just perpetually grow. Our design won't exactly thrive in this environment, especially because it's a completely different beast. You're worried about very different priorities. You're more worried about an effective use of space and not say, finding food and avoiding your opponents. And lastly, we got 2 more. So one is called Royale. Things get pretty interesting here. We see those hazards starting to appear, and they start encroaching from the various sides, squishing the snakes into a smaller and smaller box. And then one that the Battlesnake community has been putting together is called Snail. So they run these tournaments, and lately the tournaments have been using this snail game mode, where each snake has a trail of the hazards behind it as this kind of hazardous slime that will kill any snake behind it. And so, yeah, it's pretty self-explanatory. It's been really interesting to see how that changes, and you get these sort of dynamic mazes as everybody's running around. And those Minimax bots that I was talking about really don't seem to like this. So again, I keep using words like simple to lull you into a potentially false sense of security, but I don't want to lose sight of what we did learn together today. We learned about flood filling to avoid tight spaces. We got into some pathfinding like A star, and we got into this height mapping technique to try to better understand nuances on the board and to bake a lot of information down into something a little bit more manageable. So where do I think you go from here? Well, hopefully to a break, because that's next. But otherwise, I hope I've convinced you to try Battlesnake, write some JavaScript, and handle some webhooks, and play some games. You can do that at play.battlesnake.com. That part really wasn't a joke. And if you have any questions about anything that I've talked about today, find me around the conference or send me an email. Thank you so much for your attention today. It was a very generous gift.